Good evening. Welcome to Clear Concept Academy Pune. I am Sharvaree Deo. We are going to start with the series of revision questions of different chapters of mathematics and science for CBSE Class 10. This session is going to focus on the chapter Linear Equations in Two Variables. We are going to solve the multi-choice questions, that is MCQs. So let's start. So the very first question is, the nature of the graph lines of the equations 5x minus 2y plus 9 is equal to 0 and 15x minus 6y plus 1 is equal to 0 will be. Now you've been provided with the choices as well. So whenever you are given or you are asked to find the nature of the lines, graphical nature of the lines, that time you should be aware of these relations. You should also be aware with the general form of the linear equations, which is a1x plus b1y plus c1 is equal to 0, and the second equation is denoted as a2x plus b2y plus c2 is equal to 0. And to decide the nature of the lines or the graphical representation of the lines, also to decide the kinds of solutions that we get, we should know the relationship between the coefficients. So for this first question, we'll start writing down the equation, which is 5x minus 2y plus 9 is equal to 0, and the second equation is 15x minus 6y plus 1 is equal to 0. So a1, b1, c1 are the coefficients belonging to the first equation. a2, b2, c2 are the coefficients belonging to the second equation. So from the first equation, the coefficients are 5, minus 2 and 9, and the coefficients of the second equation are 15, minus 6 and 1. Remember that the sign belongs to the coefficient. So in this case, we take minus sign along with 2, and in this case, we take minus sign along with 6. So if we reduce these numbers, what do we obtain is, so plus minus becomes plus. So what we obtain is a1 upon a2 is 1 upon 3, b1 upon b2, which is minus 2 by 6 getting reduced to 1 by 3, and c1 upon c2 is 9 upon 1. So we get a1 upon a2 is equal to b1 upon b2 not equal to c1 upon c2. So the graphical representation of this pair of equations is parallel. So option A is the correct option. Now let's move on to the second question. Second question reads, what will be the nature of the graph lines of the equations 2x plus 5y plus 15 and 6x plus 15y plus 45? Again, we have to use the understanding of the relationship among the coefficients of the equations. So here you can see that the equations are 2x plus 5y plus 15 is equal to 0, and the second equation is 6x plus 15y plus 45 is equal to 0. So the a1 here is 2 upon a2 is 6, b1 upon b2 becomes 5 upon 15, and c1 upon c2 becomes 15 upon 45. So once we reduce them, we get all the ratios to be 1 upon 3. Therefore, we get a1 upon a2 is equal to b1 upon b2 is equal to c1 upon c2. So we see that whenever such case occurs, the lines, they have to be coincident. That is, they fall on each other. So in this case, the option B is the correct option. I hope it is clear. Let's move on to the next question. Question number 3. So question number 3, again let's read the question. So what does it read? So it reads, what will be the value of k what will be the value of k if the lines given by 3x plus ky minus 4 and 5x plus 9 plus k times y plus 41 represent two lines intersecting at a point. Remember that whenever there are two lines intersecting each other, that time the relationship between the coefficients is given by this. A1 upon A2 is not equal to B1 upon B2. So from these two equations, what we obtain is that the equations are 3x plus 4 plus ky minus 4 is equal to 0, and the second equation is 5x plus 9 plus k times y plus 41 is equal to 0. So your A1 upon A2 is 3 upon 5 and B1 upon B2 is k upon 9 plus k. So for lines to be intersecting, this relationship holds true, which is A1 upon A2 not equal to B1 upon B2. So A1 upon A2 not equal to B1 upon B2. Therefore, we substitute these values. So 3 upon 5 is not equal to k upon 9 plus k. Therefore, even though this is inequality, we solve it the way we solve the equations. Even though the sign here is of inequality, we solve this relationship the way we solve the equations. So this will go here, cross multiplying. So this becomes 3 into 9 plus k is not is equal to 5k. Therefore, 27 plus 3k is not is equal to 5k. So 27, 3k goes there, gets subtracted, thereby giving us 2k. Therefore, k should be not equal to 27 upon 2. This 2 is multiplying on this side, it goes and gets divided on the other side, or it divides the other side. Therefore, the answer is k is not equal to 27 by 2. If you check the option D is the correct option. Now let's move on to the next question. What will be the value of k? Again, they have asked us to find the value of k, and they have given us the kind of lines or pair of lines that we have. Okay, so what will be the value of k if the lines given by x plus ky plus 3 is equal to 0 and 2x plus k plus 2y plus 6 is equal to 0 are coincident? So when the lines are coincident, which relationship holds true? It is this relationship. Okay, A1 upon A2 is equal to B1 upon B2 is equal to C1 upon C2, and whenever the lines are coincident, they have infinitely many solutions. Okay, so here let's write down the equations. So the equations are x plus ky plus 3 is equal to 0 and 2x plus k plus 2y plus 6 is equal to 0. Now A1 upon A2 becomes x means the coefficient is 1, 2x the coefficient is 2, B1 upon B2 is k upon k plus 2 and C1 upon C2 is 3 by 6. So if we use only this part to solve the given condition to get the value of k, what do we obtain is that A1 upon A2 is equal to B1 upon B2. So we get 1 upon 2 is equal to k upon k plus 2. So cross multiply, we get k plus 2 is equal to 2k. Therefore, once we solve this equation, this k is getting added on this side. When we send it to other side, it gets subtracted. So you get 2k minus k is k, so you get k is equal to 2. So the correct answer or the correct option here is option B. So let's move on to the next question. Question number 5. The lines 5x minus 7y is equal to 13 and 10x minus 14y is equal to 15. We have to check whether they are consistent or inconsistent. So when are the lines said to be consistent? When either they are intersecting or they are coincident, then the pair of lines are called as to be consistent. And when the lines are parallel, that pair is called as an inconsistent. So again, we have to check the relationship between the coefficients of both the equations. So in this case, even though this equation is not in its standard form, we can see that the constants, both the constants are lying on the RHS. We are going to use them as it is. So here, a1 upon a2 becomes 5 by 10. b1 upon b2 becomes minus 7 upon minus 14. And c1 upon c2 becomes 13 upon 15. So if you see, a1 upon a2 gets reduced to 1 upon 2. b1 upon b2 gets reduced to, since both numerator and denominator are negative, the minus sign gets cancelled and they get reduced to 1 upon 2, and 13 upon 15 remains as it is. Therefore, the relationship a1 upon a2 is 1 by 2. b1 upon b2 is again 1 by 2, but this is not equal to c1 upon c2. Therefore, the lines are parallel and the system of these two equations is inconsistent. Therefore, here the correct option is option B. Now let's move on to the next question. So next question is, if one equation of a pair of dependent linear equations is minus 3x plus 5y minus 2 is equal to 0, then we have to figure out the second equation. For that, you must understand that what is meant by dependent equations. So whenever the two equations represent coincident lines, that time the two equations are called as the dependent equations. So when do the two lines are coincident? When we have a1 upon a2 is equal to b1 upon b2 is equal to c1 upon c2. So in this case, we'll have to check which equation fulfills this condition. So let's write down the original given first equation as it is. So here the first equation is minus 3x plus 5y minus 2 is equal to 0. Therefore, you have a1 is equal to minus 3, b1 is equal to 5 and c1 is equal to minus 2. Now if you check the first equation itself, okay, so here you can see that in the given options, the coefficient of x is in all the places it is 6, isn't it? So if we consider 6, that time a1 upon a2 will become minus 3. I am going to consider the first option. Here you will have to check option by option. So if I consider the first option, option A, whose equation is minus 6x plus 10y minus 4 is equal to 0. So a1 in this case is minus 3, b1 is minus 6. So we get a1 upon a2 is equal to 1. Now b1 upon b2 becomes, we have b1 is equal to 5, b2 is equal to 10, and this gets reduced, giving us b1 upon b2 is equal to 1 upon 2. Till this point, this equation in option A is fulfilling this condition. Now we have to check c1 upon c2. So c1 upon c2 becomes, c1 is minus 2, and in this case the c2 becomes minus 4. Since both numerator and denominator are negative, minus sign gets cancelled and it gets reduced to 1 upon 2. Now here we can see that we have a1 upon a2 is equal to b1 upon b2 is equal to c1 upon c2. So luckily here first option is fulfilling the given condition. Therefore option A is the correct option. So let's move on to the 7th question. It reads that if a pair of linear equations is consistent, then the lines represented by them are. Now if you refer to the notes written here, you can see that the consistent pair of equations means what? It means that if the lines are intersecting or if the lines are coincident. So whenever we say that we have a consistent pair of equations, remember that there are two possibilities. Either the lines are intersecting or the lines are coincident. So if you go through the options, so the option reads that the lines are parallel. Are the lines parallel in case of consistent pair of equations? No. Are they always coincident? Is that the case? No, they are either coincident or intersecting. So even option C gets discarded, which says that always intersecting. Therefore, the correct option is when the pair of equations is consistent, the lines are either intersecting or coincident. Therefore, option D is the correct option. So let's move on to the next question, question number 8. So here we have to find the values of A and B. They have given us the equations, that is a minus 1 times x plus 3y is equal to 2 and 6x plus 1 minus 2b times y is equal to 6. They also have given us the information that the given pair of equations has infinitely many solutions. So whenever a pair of equations has infinitely many solutions, that time it fulfills this condition, that is a1 upon a2 is equal to b1 upon b2 is equal to c1 upon c2. So we are going to use this relationship to find the values of a and b. So we'll write down the values of a1 upon, I'll write down the relationship first. Now we'll substitute the values. A1 is a minus 1 upon a2 is 6. B1 is 3 upon B2 is 1 minus 2B, and C1 is 2 upon C1 is 2 and C2 is 6. Now as you can see in both the equations, the constants C1 and C2 are lying on the RHS. Hence I am going to use them as it is and not going to convert the given equations in the standard form. So you should ensure that if the values of C1 and C2 both are lying on the same side or RHS, then and then only you can use them like this. Okay, now to find the value of A, I am going to use these two ratios. So it becomes A minus 1 upon 6 is equal to 2 by 6. Now here, the denominator of entire LHS is 6 and denominator of entire RHS is 6. In such cases, the denominator gets cancelled, thereby reducing the equation a minus 1 is equal to 2, therefore giving you the value of A as 2 plus 1, 3. Actually, if you go through the options given here, you can see that there is only one option in which you have value of A is equal to 3. So you sort of have arrived to the final answer that option C is the correct option. But here we are going to solve the question completely and find out the value of B. So to find the value of B, we are going to use these two ratios, which is 3 upon 1 minus 2B is equal to 2 by 6. Now here I can reduce 2 by 6 to 1 by 3. Therefore the equation becomes 3 upon 1 minus 2B is equal to 1 by 3. To solve it, we'll cross multiply. Therefore 3 into 3 is equal to 1 into 1 minus 2b is 1 minus 2b. Therefore 1 minus 2b is equal to 9. Now we have to move this 1 to the other side. Since there is a plus sign to its LHS, when we are sending to RHS, it will have minus sign. So you have minus 2b is equal to 8. Therefore b is equal to 8 upon minus 2, thereby giving you b is equal to minus 4. So you can see that the values that we've obtained are A is equal to 3, B is equal to minus 4. Therefore option C is the correct option. Now next move on to the 9th question. So we have the equations as x plus 2y plus 5 is equal to 0 and minus 3x minus 6y plus 1 is equal to 0. And based on the given two equations, they have asked us to find the type of solutions the pair can have. So to decide the kind of solutions the pair can have, again we have to check the relationship among the coefficients of the two equations. So we will write down the ratios as a1 upon a2, b1 upon b2 and c1 upon c2. So here a1 is 1 upon a2 is minus 3, b1 is 2 and b2 is minus 6. So 2 upon minus 6 gets reduced to 1 upon minus 3. Here we can see that we have a1 upon a2 is equal to b1 upon b2. So either this condition will hold true or this will hold true. Now c1 upon c2 becomes 5 upon 1. So what we've obtained? We've obtained a1 upon a2 is equal to b1 upon b2, which is not equal to c1 upon c2. Which condition is this? It is of inconsistent pair of equations where the lines are parallel and parallel lines do not have any point common between them. Therefore, in this case, the answer is no solution. The correct option here is option D. So D is the correct option, that is no solution. Now move on to the next question, that is question number 10. So the question number 10 is, again they have given us two equations, y is equal to 0 and y is equal to minus 7. So for these two equations, again they have asked us to find the kinds of solutions. Now here you must understand, here you can see that both the equations have variables only, y variable, x variable is absent. Here you must understand what does this equation mean. Y is equal to 0 is the equation of x-axis. This is the equation of x-axis. Whereas y is equal to minus 7 or y is equal to constant is always the equation of a line that is parallel to the x-axis. So this is the line parallel to the x-axis. So what information do we gather from these two statements? We have one line which is the x-axis, the other line is parallel to the x-axis. So these two equations represent two parallel lines. Again, two parallel lines do not have any point common between them. Since they do not have any point common between them, there is no solution. So the correct option is option B, that is no solution. Option B is the correct option. Let's move on to the next question. I hope the speed is fine. You are following the discussion, the explanation. Okay? Do let me know how do you feel about the explanation. Let's read the next question. Now the next question is sort of a theoretical question. So it reads that if the pair of linear equations has a unique solution, then the lines representing these equations will be. So when we say that two lines have a unique solution, it implies that the two lines are intersecting at only one point. When we say that a pair of equations has unique solution, it means that the two lines are intersecting at only one point, and which is that case? It is this case, that is a1 upon a2 not equal to b1 upon b2. So the option here is that correct option is option B, that is the lines intersect each other at one point. Remember, a pair of equations having unique solution implies that lines intersect each other at only one point. So the correct option is option B. So for question number 11, the correct option is option B. Let's move on to the 12th question. The pair of equations x is equal to a and y is equal to b. So what kinds of lines are they? X is equal to a and y is equal to b. X is equal to constant means the line is parallel to the y-axis. And y is equal to b means the line is parallel to the x-axis. So how does it look like? So if this is your x-axis, this is your y-axis, this is your origin. Let's assume that this is x is equal to a, the line will be like this. So the x coordinate of all the points lying on this line is x. Okay, this line is x is equal to a. And suppose this is b, then this line is parallel to the x-axis. So the y coordinate of all the points lying on this line is always b. Therefore, the coordinates of the point here are a comma b. And solution of a pair of equations is the coordinates of the point of intersection. Here the coordinates of point of intersection are a and b, a comma b. Therefore, the correct option is the pair of equations x is equal to a and y is equal to b graphically represents lines which are intersecting at point a and b. Therefore, option B is the correct option. Therefore, option B is the correct option. Let's move on to the next question. Question number 13. So question number 13 reads, when lines L1 and L2 are coincident, which is that case? This is the case. So what happens when the lines are coincident? We have A1 upon A2 is equal to B1 upon B2 is equal to C1 and C1 upon C2. And when the lines are coincident, how many solutions does it have? When the lines are coincident, it has infinitely many solutions. So this is the answer. So when lines L1 and L2 are coincident, then the graphical solution system of linear equations has, correct option is option A, that is infinitely many solutions. So for question 13, the correct answer is option A, that the system of equations will have infinitely many solutions. Now let's move on to the 14th question. So it reads that the graphical representations, so they have given us the equations. I must write down the equations. So what are the equations? 4x plus 3y plus 1 is equal to 6 and 12x plus 9y is equal to 15. So what do you think? How should we decide, right? How the graphical representation looks like. So here we must check these relationships, right? So if we, at a quick glance, what do I see? 4 upon 12 is 1 by 3. Then 3 upon 9 is again 1 by 3. And if I quickly have a look at the RHS, RHS is what? It is 6 upon 15, which is 2 by 5. Oh, so what do I observe? A1 upon A2 is equal to B1 upon B2 and not equal to C1 upon C2. So I'm very much tempted to choose the option as the lines are parallel, isn't it? So, but if you see, the twist that they have added here is by means of this plus 1. We'll have to solve this part first and then we'll have to arrive to the conclusion. So I'll solve this equation. So 4x plus 3y, I send this 1 to RHS, 1 is getting added here, it will go and get subtracted. So 6 minus 1 gives you 5. Now with this, I can solve. So A1 upon A2 becomes 4 by 12, which is 1 by 3. B1 upon B2 is 3 by 9, again 1 by 3. And C1 upon C2 is 5 upon 15, again 1 by 3. So I observe we have A1 upon A2 is equal to B1 upon B2 is equal to C1 upon C2. That is, the lines are coincident. So which is the correct option? Option B is the correct option. So for question number 14, option B is the correct option. The next question is, what is the graph of line given by the equation x is equal to minus 2? Now, based upon the discussion up till now we had, I'm sure that you should be able to answer this question. So what is the format of this equation? It is x is equal to some constant. X is equal to minus 2. So x is equal to some constant represents a line that is parallel to y-axis. x is equal to some constant always represents a line that is parallel to y-axis. So here the correct option is, what is the correct option? Quickly. So we have, for question number 15, the correct option is option B. So we have option B. That was quite quick, right? Let's move on to the 16th question. Quite an interesting, huh? You should read the questions carefully, because when we are solving the paper, we are always in hurry. I want to solve this very quickly. This seems to be very, very simple, very, very straightforward. But you should read each and every word given in that question. So what does this question read? The question reads, which of the following is not a solution? Isn't it? The question reads that which one of the following is not a solution of the pair of equations 3x minus 2y is equal to 4 and 6x minus 4y is equal to 8. In such cases, what should be the approach? Simple. Choose the option, substitute the values of x and y in the given equations, and verify if LHS is equal to RHS. There is no other way. Okay, there is no other shortcut. So, question number 16. So they have given us equations 3x minus 2y is equal to 4 and 6x minus 4y is equal to 8. So the first option is x is equal to 2 and y is equal to 1. So if I substitute in LHS, so 3 into 2 minus 2 into y gives us 6 minus 2, that is 4. Similarly, here we get 6 into 2 minus 4 into y, that is 12 minus 4, that is it gives 8. So LHS is solved to 4, RHS is 4. Here LHS is 8, RHS is 8. So option A is the solution of the given equation. So that is not our answer, because we are finding out which is not the solution. Okay. Now next, we have to check x is equal to 6 and y is equal to 7. So 3 into 6 minus 2 into 7, 6 3s are 18 minus 14 gives you 4. So your LHS is 4, RHS is 4. So this holds true for the first equation. For second equation, it becomes 6 into 6 minus 4 into 7. 6 6s are 36 minus 7 4s are 28. The difference is 8. Therefore, the second option is also the solution of the given pair of equations. So this is not our answer. Now we'll move on to the third option, which is x is equal to 5 and y is equal to 3. So 3x becomes 3 into 5 minus 2 into 3. 5 3s are 15 minus 2 3s are 6. That gives me 9. So LHS is evaluated to 9. RHS is 4. So since LHS and RHS are not equal, this is not the solution. This is not the solution of the given pair of equations. So in this case, option C is the correct option. So since we've got our answer in option C itself, we don't move on to the option D. So let's move on to the 17th question. So they have given us a pair of equations and also have provided us the information that the pair has infinitely many solutions, and the options give us the relationship between the values of A and B. So here, to decide that relationship, first we should understand that we have to use this relationship in which we get to know that the equations or the lines represented are coincident and it has infinitely many solutions. So what is the condition? It is A1 upon A2 is equal to B1 upon B2 is equal to C1 upon C2. Substitute the values. A1 upon A2 is 2 upon 2A, 2 upon 2A. B1 is 3 upon B2 is A plus B. C1, As you can see in both the equations, the constants are lying to the RHS. Hence, I am going to use these equations as it is and not going to convert into the standard form. So here we have 7 upon 28. Now, as you can see that we have 3 ratios here. I am going to use these 2 ratios to find the relationship between A and B. Okay, so the ratios are, you can see 2 upon 2a gets reduced to 1 upon 1a. So we are going to start with 1 upon a upon 3 upon a plus b. Cross multiply. So a plus b is equal to 3a. So this a is getting added on this side. If I send it to other side, it will get subtracted and will give me the relationship between A and B as B is equal to 2A. Do we have this option? Do we have this option? Yes, of course. Which option is it? It is option A. So in this, or for this question, question number 17, the correct option is option A. Okay, so option A is the correct option. We are almost nearing to the 20th question mark, right? So we are coming or moving ahead to the question number 18. So you can see that up till now, I even included question number 18. How were the questions? The questions involved the relationship between the coefficients of the equations. And based on these relationships, we checked whether the system of equations is consistent or inconsistent, whether the graphical representation is of intersecting lines, coincident lines, or parallel lines. Also, we checked whether the system of equations has no solutions. So when the lines are parallel, it has no solutions. If the system of lines has infinitely many solutions, when the lines are coincident, it has infinitely many solutions. And when the lines are intersecting, the system of equations has only one unique solution. Okay? So, let's move on to the 18th question. So, they have given us that x is equal to a and y is equal to b are the solutions of the given pair of equations. So, what are those equations? X minus y is equal to 2 and x plus y is equal to 4. We have to find the values of a and b respectively. How do we go about? How do we go about it? Of course, we have to use the techniques, either the elimination method or the substitution method. My personal favorite is elimination method. Okay, so I'm going to use the elimination method. So we have two equations, x minus y is equal to 2 and x plus y is equal to 4. If I add these two equations, y gets cancelled, giving you 2x is equal to 2 plus 4 is 6. So x is equal to 6 by 2 is 3. So x is equal to 3. How many options does have x is equal to 3? Now interestingly, what they have done here is that the question reads that if x is equal to a and y is equal to b is the solution of the pair of equations x minus y is equal to 2, x plus y is equal to 4, then the values of a and b are respectively. Okay, respectively means in the given options, first value will correspond to the value of a, that is x, and second value will correspond to the value of b, that is y. So we have obtained x is equal to 3, that is we have a is equal to 3. So how many such options are there? There are two options, option A and option C. To find the value of y, we can simply substitute the value of x in one of the equations. So 3 minus y is equal to 2. So 3 minus how much will give you 2? It will be 1. So 3 is getting has plus sign to its left. Once it goes to the right, it will be minus. So you get minus y is equal to minus 1 since both LHS and RHS are negative. Minus sign gets cancelled. Therefore, you have y is equal to 1. Where y is nothing but b. So you have a is equal to 3, b is equal to 1. So option C is the correct option. So option C is the correct option. So let's move on to the 19th question. What does it read? The angles of a triangle are x, y and 40 degree. Remember that in the questions of linear pair of equations, they always give you the conditions which will help you to form the linear equations, two linear equations. So if you read this question carefully, they have given you the angles of a triangle. So if you remember the angle sum property of a triangle, it states that sum of three angles of a triangle is equal to 180 degrees. So since the three angles here are x, y and 40 degree, this equation becomes x plus y is equal to 40 degree is equal to 180 degree. Once we solve it, we get x plus y is equal to 40 gets subtracted, we get 140 degree. So this is your first equation. And the second condition that they have given us is that the difference between the two angles x and y is 30 degree. Here they have given it in a straightforward manner. X minus y is equal to 30 degree. Again, as I told you, we have to solve these two equations. You can solve these equations either by the method of elimination or substitution. As I mentioned earlier, my personal favorite is elimination. So I'll use elimination. So I'll be adding these two equations and I'll eliminate y. So plus y minus y gets cancelled. X plus x gives you 2x. 140 plus 30 is 170. So x is equal to 170 upon 2. Therefore, x is equal to 85 degree. Are there any options of 85 degree? Yes, option C is the only option that has 85 degree. So in a way, we have got our correct option. It is option C. But again, we are going to solve the complete question here and we are going to find the value of the second angle as well. So you have x is equal to 85 degree. So x plus y is equal to 140 degree. Therefore, 85 plus y is equal to 140. Therefore, y is equal to 140 minus 85 gives you 55 degree. Therefore, which is the correct option? Option C is the correct option. Option C is the correct option. Now we come to the 20th question. So this rally was of 20 questions. So we have come to the last question of the rally. So what does it read? It reads that if the sum of two numbers is 35 and the difference is 13, such a straightforward question this is, isn't it? So in such cases, the unknowns are the two numbers. We assume them as x and y. So sum is 35. So x plus y is equal to 35 and difference is 13. So either you can solve these equations the way we solve them, or even you can check the options which yield these two results. Okay. So if you are able to figure out the answer without actually solving the equations, you should mention that in the comment section. Okay. Without actually solving the two equations, just looking at the options given here, if you can figure out the answer, do comment. Okay. But here we are going to solve the equations again by which method? Elimination, of course. So here I'll be adding the two equations and eliminate y. X plus x is 2x is equal to 35 plus 13. How much is it? It is 48. So you get x is equal to 48 by 2, that is 24. And you have to find the value of y. You use one of the equations, that is x plus y is equal to 35. So 24 plus y is equal to 35. So you get y is equal to 35 minus 24. Therefore, y is equal to 11. So what is the correct answer? Correct answer is x is equal to 24 and y is equal to 11. Which is the correct option? Which is the correct option? Option B is the correct option. So, how was it? How was the rally? I thoroughly enjoyed this rally. I hope even you liked it. And I'll be giving you the questions in the comment box. You can find it in the description. Do go through the video. Do let me know your feedback. Do let me know which other topic, next topic that you would like to discuss, get described, get explained. Till then, bye bye. Thank you.